Hi there, we are Group 3 from SCR515 and we're here to explain our Sprint 2. And basically our sprint goal is to finish the rest of the Sprint 1, which is like manually control our robot. And then we're gonna have a map for the rover to browse. And then we're gonna have our own script to run the whole program and build the environment. And then let's do our demo. And to begin with, we'll run our for script to run whole thing, and it should be showing in a second. As you can see, the rover status is showing the RBIZ, and this is the map, which is our user story, like build a map in the system. As you can see in the gazeable. And then we're gonna have, by using our script, to see how the rover can be controlled manually. So there are two scripts. The first one is like to give it like a fixed control, like give it a fixed speed. Like you can see in the gazeable. And then I'm gonna show the other one, which is a manually control. As you can see, we have several commands, like use W to make it move forward, and as you can see in the menu, I just pushed A to make it turn, and then I make it move forward as you can see. Yeah, basically that's all we have done for this sprint, like make the rover move manually, and we have the map right now, and then we have our own script to build and run our software. And Matt, do you want to go to the
Yeah.
what's that?
All right. So in this sprint, our business value to the customer would be implementing a map, a real world map for the robot. And also in the previous sprint, we had some problems with manual controlling of the robot and movement of it around the environment. This sprint, we have implemented steps to counter that problem, and we have manually controlling options here, which we can move the robot in four directions, and we can make it go forward and backward. Not backward, just stop and rotate on its axis. And the second one, like we said, we have built a map which the rover can move around. All in all, this sprint was very beneficial. We managed to finish all our user stories, and we have no impending task for the next sprint. We would say we did really well in achieving our tasks. We were on time with things, and moving forward, we will be implementing some new features like automatic movement, along with a better UI for control of the manual control of the robot, along with automatic movement with collision avoidance. Thank you so much.
Hi, we're Group 3 from SCR515, and we're here to explain our Sprint 3 of our autonomous moving rover program. And for this sprint, our goal is to first, we have our GUI for user to interact with our software, and then we're going to have the rover to move autonomously, and then we're going to have the map customization feature. And first, I want to show you how we're going to customize our map. So after we run the program, we're gonna ask users like the size of the map he or she wants, for example, like 7 meters, and then gonna ask for a density, like the distance between each obstacle. Let's say 2 meters here. And then our new map is gonna generate and gonna be fitted to our program later. And then we're gonna run our program with our new GUI. And Matt, go ahead and explain the GUI a little bit.
Yeah, so basically our GUI lets us control the entire software that we have for our rover. So the first step would be to just, build a project. What building the project, it initializes space and builds all the run files that we need for our program. So once that is done, it'll launch the required need to, watch and see our robot move. So here is our map gazebo and also have our robot visualization. Once that is done, what we do is we select the autonomous movement. So once we'll be able to see the robot make its own decisions. So the robot will start moving, see, right? And yeah, we are waiting for it to move to, explore the spaces around it. So right now it is trying to go straight. Uh, One of the features that we have for this, even though it is highly, is it can detect objects and avoid collisions. And once it's stuck in a hard place, it can we it can automatically decide its way out. So right now you can see it has a hard place. Now it's compute how to get out of it. Give it some time. It should, yeah, like you can see, it's moving itself out on its own. Yeah, once uh, once that is done, this just shows us that our collision avoidance system is working in our autonomous role. Yeah, and it'll start exploring. We also have built a manual option in case the rover gets stuck. It is still in its early stages, but it does do the job what we tell it to do. Basically, in case the rover gets stuck, we can manually input controls to the rover. Like here, we can make it go forward by pressing W, come backwards by pressing S, and we can make it stop by pressing Q. It works just fine. Yeah, like you can see, it works fine. Yeah, that was basically our entire deliverable. Like Sheng, we had major three goals for the sprint, which build our GUI for entire work control. We had to build our map customization. We should have given map customization option to the user, and also the third one was autonomous. In terms of business value, from previous, we added the option for GUI, and the main second point would be to give the option, I mean, the ability of the rover to move on its own, give it autonomous maneuverability. And lastly, we also give the user the opportunity to add and customize map. So that basically is our delivery. In terms of our sprint 3, you can see the burn down right now. We work very well. Even though we had a break, we managed to do our things very well. We divided our tasks and we were able to achieve all our goals for the sprint. Thank you so much.
Hi, this is Jordan. I worked on the Docker in this sprint. A big advantage of the Docker is that it takes away repetitive configuration tasks. So we can deploy our project in any operating system and only need 10 minutes. So I will gonna show you that how to do that. So this is in our Windows system. So here we are deploying our project in Windows. Um, so I would say it's faster than running our project in the VirtualBox.